Hello again, or possibly for the first time. I am Michael Steele. I'm one of the teachers in the Accelerated Math 3 cluster, and I'm going to be working through the Math 3 Essential Skills Quiz model, trying to help sort of provide you with some nice refreshers of how to approach the problems that we have in this tool for you to use. So what I'm going to do is I'm going to, of course, solve each of the problems. I believe the section we're looking at in this one has 3 questions for it. I can verify, yep, we have 3 questions. Work through each one, talk a little bit about sort of the techniques that I'm using, try to make it as clean and clear as possible what's happening, and just try to support you as you approach these, more or less weekly, but pretty frequent essential skills quizzes that test you on some of the things you've seen before. So in this first one, we're going to be focusing on linear equations. So basically equations where there's nothing squared, there's no factoring that has to be done. It's just basic algebraic techniques. And without further ado, let's go ahead and begin to attack that first problem. So as the instructions say here, in question 2a, and all of the questions here, solve for x, and we're supposed to leave our answer exact. In other words, we're going to get a fraction answer potentially. So we need an exact answer each time, and I am going to stick with that convention. So in this first one, we have 8x plus 3 equals 5x minus 7. Now, if you want to solve this graphically, there's a problem on this essential skills quiz that features solving graphically. But that's not our goal here. Our goal here is to just do basic algebra. And of those techniques that we're going to use, probably the most important one to start off with is just to collect like terms. What that means is we're going to try to get all the x terms, the linear terms, the terms with an x in them, onto one side, combine them together so we have just one of them. We're going to try to get all the constant terms, in other words, just the numbers on the other side. Then we're going to solve for the actual x value to find the missing value itself. So what that's going to look like here, it'd probably help if we had this written out pretty large. So let me go ahead and make it just a little bit bigger for us here. So I do these on a large screen. I'm imagining most of you will do these problems or watch these videos on your Chromebooks, but theoretically you can do it on your phone. Hopefully this helps with your vision a little bit. So there is our equation. What I'm going to do is twofold. The first thing I'm going to do is I'm going to get all the x's together. I'm choosing to bring the 5x over to the left side. Now I could have done it the opposite way and brought over the 8x. There's nothing wrong with doing it that way. I just wanted to keep things positive as much as possible. Stay positive, keep things, optimistic and such. So I'm going to subtract the 5x. Of course, the value there is that when you subtract 5x from both sides, that makes a 0 over here. 5x minus 5x is 0, so that works out really nicely for us. Now, having said that, we're going to end up with 3x on the left side. And what that means is that if we want to solve this equation, in a fast, efficient way, we need to get the plus 3 on that left side over to the other side. So I'm going to subtract 3 from both sides. Again, always operating in this sort of balance, this equilibrium of doing the same thing on both sides. So that's going to give us, just like before, a 0 on the left side. But on the right side, we're going to end up with minus 7 minus 3, which is going to be minus 10. So that means where we've arrived is at the equation, let's do it in black here, 3x equals negative 10. So if we're trying to solve 3x equals negative 10, we need to get x by its lonesome. Currently we are multiplying x by 3. We're going to divide both sides by 3 or multiply by 1/3, however you want to think about it is fine. That will, in this case, not create a 0, but it will create a 1. That'll leave us with an x on the left side. And on the right side, we have negative 10/3. If you wanted to express that a different way because you like to be different, that's cool. You could express that as negative 3 and 1/3. That'd be perfectly fine. It's a mixed number, still fractiony, still exact. But there's our fraction answer. So negative 10/3 is our answer to question 2a. Question 2b, it's similar, obviously still linear. We've still got x's and stuff here, but in this case there's only one x, so that's kind of interesting. Collecting like terms will be a little bit easier just because we won't have x's to move around in addition to a constant. But in this case what we have that's a little bit different is that set of parentheses here. We are multiplying out, or we're first doing 2 times the quantity 4x plus 11, and then we're adding 3, and it's all equal to negative 6. So where I want to begin, again, is with the techniques here. The first move I want to make, it's sort of up to you. There's a couple choices here. But I want to start here. I'm going to distribute, aka use the distributive property, to bring that 2 in here. So that way we don't have any parentheses or any multiplication really to deal with anymore. So 2 times 4x is going to be 8x. And 2 times 11 is going to be 22. Now we have 8x plus 22 plus 3 equals negative 6. And obviously I could have also brought that 3 over to the right side and subtracted 3 from both sides. I chose not to because here we can just combine them together. So we have plus 22 plus 3. This is going to end up being 8x plus 25 equals negative 6. Now, we still have to, combine like terms and get all the pieces on the correct side. So since we've already got a minus 6 on the right side, I'm going to go ahead and subtract 25 from both sides. So, for some reason, I have not made a video in the last few weeks, or just because of summer, and also had COVID at the end of the school year, so it's the first one in a little while. But in any event, there is 8x equaling negative 31, and then just like we had before, we want to make a 1 here so that the x is by its lonesome, so I'm going to do precisely that by dividing both sides by 8. When I do, that's going to give us our answer. X is equal to negative 31 over 8. And there is our solution. So in this case, the big new addition, not really new, you've done this for quite a while, but we had the distributive property that we had to use there as opposed to just sort of collecting like terms, although we did end up collecting like terms by the end. Our final problem is, well, it's got all of it. It's all here. If you had fun with the first two, well then, let's just have a little bit more fun here. So once again, making this just a little bit larger, just so you can really see my work as I proceed through here. So what do I got to do? Well, we've got 6x plus 7 times 3x minus 2, all equal to some other stuff. Basically, we have distributive property, combining like terms. We just got a mess of stuff. So I'm going to start with the distributive property. Again, your approach may vary, but it's going to be pretty necessary. This will make it as clean as possible, I want to say. So where that'll leave us is with 6x plus 7 times 3x, or 21x, and then 7 times negative 2 is minus 14. All of that's equal to 12x minus 8. The next thing I want to attack are any like terms that I can. I see one set right there already combined together. So 6x plus 21x is going to be 27x. Obviously, we still have minus 14 equals 12x minus 8. But at this point, we can start to move some stuff around and start to combine like terms. Just like before, I want to keep everything positive, so I'm going to move negative 12x over by subtracting it from both sides. I'll draw my little line there as well. Now, likewise, just like we did on one of those earlier problems, if we want to get all the x's on the left side, we should get all the constants, or the numbers, the integers in this case, over to the other side. So I'm going to do exactly that. I'm going to add 14 to both sides. Now first, when we combine the x's, 27x minus 12x, it's going to leave us with 15x's. We're going to get a 0 for the minus 14 plus 14. We're also going to get a 0 for the 12x minus 12x. These were both our goals. There's no surprise here. And then finally, we have minus 8 plus 14, which is going to be 6. Now from here, we can divide both sides by 15. And going to be a little bit interesting in this case. So the 15s divide out, make a 1. That's going to give us x equals 6 over 15. Now 6 over 15 is correct. It is an exact answer, and it's in fraction form, but it's not in simplest form. So keep in mind, 6 is the same thing as 2 times 3, and 15 is the same thing as 5 times 3. And of course, if we write it in such a way, we can see right there that the 3's will divide out, and that's going to give us a simpler version of our answer. X is equal to 2 over 5. So, and I don't want to make any claims about whether or not your teacher will accept 6 over 15. So just to play it safe, simplify it all the way through. Didn't take too long to do so, and I think it comes out pretty nice. 2/5 is the answer. So with all that said, you've gotten your quick refresher on sort of those Math 1, maybe even Math 7 and 8 algebraic skills here solving equations. Just as a quick little recap, we started by just sort of two-step equationing our way through here by combining like terms, moving the x terms to one side and the constants to the other. After that, we were reminded of the distributive property, which allowed us to distribute that little scalar, that number out in front, into a linear expression there, a binomial, and that allowed us to then solve like before. And finally, we just said, you know what, let's just put them all in one equation, and let's do it. And we did precisely that, and we were able to solve it just fine. So hopefully that jogged your memory a little bit with some of these techniques. Again, they're things that you probably have used pretty frequently in your math education in the last couple of years, but at the same time, they're skills that are super essential in this course and going forward. So in any event, I hope this video was helpful for you. Thank you for watching, and have a great day. Night? Or summer? Thanks for playing.